Alright guys, so for the calculator, again, you have to make sure you push these buttons or else it's going to be difficult to do what you need to do. So first you want to turn the Scatterplot on so that you can graph a scatterplot in your calculator and you can actually see the scatterplot. So to do that, you hit the second button, then y equals. You'll see a bunch of plots that say plot 1, plot 2, plot 3. Click plot 1, so hit enter. And then there should be a blinking cursor over on. Hit that so that on is highlighted. Now plot 1 is on, so this means you will be able to see a scatter plot. Now if you just hit y equals, you'll see at the top plot 1 is highlighted. That means that you're able to see scatter plots. If you ever just want to go back to graphing lines and you don't want to see the scatter plot, you're going to turn plot 1 off. So you can only do either scatter plots or lines. You can't do both at the same time. So if you want scatter plots, plot 1 has to be highlighted. If you don't want scatter plots, plot 1 should not be highlighted. So just make sure you keep that in mind if ever your window looks weird when you're graphing. Then you need to turn diagnostic on. So you hit, everybody needs to do this. Some of you are not.
I still have my homework. I mean, warm-up.
This is the warm-up?
Yeah.
Okay. So you hit second 0. There goes the catalog. It'll be a long list of words. You're going to scroll all the way down until you see diagnostic on. Diagnostic off comes first, but we want diagnostic on. Scroll all the way down till that little arrow is pointing to diagnostic on, and then hit enter, and enter one more time, and done should pop up on your screen. So you should only have to turn diagnostic on once, but if you ever reset your calculator or your calculator isn't giving you the equation that it's supposed to, then just double check, make sure diagnostic is turned on. Okay, so just hang on to this warm up so that you have these directions in case something starts looking weird. So just hang on to the warm up so you have the directions with you. Okay. All right, then we're going to go ahead and move on with our notes. So a scatter plot, you may remember we have a coordinate plane, and then you're plotting points on a scatter plot. It's usually data that you have collected. So it's a point, so there's an x value associated with it and a y value, and you'd put a point. So a scatter plot is a visual representation . A visual representation of the relationship between two data values. And again, they'd be x and a y. All right. So with this scatter plot, we can use what's called a linear regression line to kind of define this relationship algebraically instead of just visually. So a linear regression line, as the name suggests, is a line. So we have y equals mx plus b. Our favorite way to write the equation of a line. But it is a line that best fits the data, or that best explains the data. So line of best fit, same idea. Now it's the line that best fits the data, which means it's not perfect, because it is a scatter plot. Very rarely will all your points on a scatter plot be exactly in a straight line. So the linear regression line does its best to explain the data. And just like with our regular equations of lines, our slope, or m, is the slope, which is saying the slope is rise over run, so it's every change in y for one change in x. Change in y for every change in x, and then b, our intercept is the starting or initial value, I'll call it, which is when x equals 0, because it's the y-intercept, it's on the y-axis. Any point on the y-axis has an x value of 0. So the components of a line are still the same with what we were doing yesterday. We're just now using a line to describe a scatterplot. So something else that also goes along with the linear regression line is called the correlation coefficient. This is represented by the lowercase letter r. And the correlation coefficient basically tells you how strong the relationship is, or how good of a job the line is doing of describing the data. So it describes the strength of the relationship, and the direction, meaning positive or negative if your data is increasing or decreasing. And r is always going to be from -1 to 1. So you can't have a correlation coefficient that's less than -1, and you can't have a correlation coefficient that's larger than 1. Okay, so some different types of relations. It's kind of hard to see on the screen, but you have it on your paper. So if we have a positive relation, which is like in this first row here. Positive relation, just like a positive slope, means that your data points are increasing. So as x increases, your y values tend to increase as well. So this just means r is positive. Now if we look at the strong relation box, all of the points of your scatter plot are pretty close to the line. They look very linear. That is what makes it a strong relation. So points close to line. When we have a strong positive relation, our correlation coefficient is approximately equal to +1. So positive because it's a positive relation, and it's close to 1 because it's a strong relation. So anything close to 1, like 0.8, 0.9, anything, the closer to 1 you get, the stronger you get. Whereas when we look at a weak relation, our points of our scatter plot are very spread out, and it's not very linear. You can kind of tell that it's increasing, that your data points are going up as you go from left to right, but it's basically just an increasing blob instead of an increasing line. So the more spread out your data points are, the weaker the relation. So spread out data. And when we have a weak relation, that means your correlation coefficient is approximately equal to 0. So the closer to 1, the stronger it is. Closer to 0, the weaker it is. So like 0.2 or 0.3. Yeah. And then a negative relation, same idea, just going in the opposite direction. So when we have a negative relation, which is this bottom row here, this is where the slope of the linear regression line or your data points are decreasing as you go from left to right. And when it's negative, that means your R value, your correlation coefficient, will be negative as well. Okay, so if you notice, both of our scatter plots here, both of the lines are decreasing. They have a negative slope because we have that negative relation. And just like with our strong positive one, with our strong negative one, our points, our data points are close to the line. They're just decreasing, which is why it's negative. So points are close to the line, but it's decreasing. So when we have a strong negative relation, that means our R value is approximately equal to -1. So 1 is still representing the strong correlation, whether it be positive or negative. The sign just tells you if it's increasing or decreasing. And then with our weak correlation, our points are very spread out. But you can tell it's a blob that's decreasing. And so when we have our data points that are more spread out like this, that are decreasing, that is a weak relation, which means R is approximately equal to 0. This would be like -0.2 or -0.1. Where it's negative because it's decreasing, but it's close to 0 because it's very spread out. Okay, so these are the main ones. These are the linear relations. Write this on the side here. So strong, weak, positive, negative, that is all describing a linear relationship. If you look over to the right-hand side here, we have two other options. The first is where our data points are just one big blob. It's not increasing or decreasing. There is just no relationship at all. So this is called a no relation. Just one big blob. It's the official term, one big blob. So no relation is just there's nothing to say that those data values, the x and the y values, are related to each other at all. And then if we look at this other one below here, these data values do have a relation. They make a nice, pretty arc shape here. But is that a line? Is that a straight line? No. So this is a relationship. It's just not a linear relationship. So this is called a nonlinear relation. Oops. Where there is a relationship, it's just not linear. So the arc is just an example. Again, there could be other shapes that your data points make, but if it's not a line, then it would be a non-linear relation. Okay. Any questions so far? Okay, so on the back now, we're going to move into graphing scatter plots and using our calculator. So first, let's practice doing a scatter plot by hand. So when I give you data, for a scatter plot, it's going to have an x value and a y value. So here, like this is the point 2, 2. This is the point 4, 3, etc. Our x values are on the top, y values are on the bottom. So to do the scatter plot, you will just plot all of those points. So let's go ahead and do that together. So 2, 2, we put a point. 4, 3, we put a point. 6, 6, we put a point. 8, 9, 10. Oh, doesn't go to 11, so let's put it up here. Oops. 5, 4, and 8, 8. Rarely will you see your data this close as to a line, but we're just practicing today. So this is how you can do it by hand. To use our calculator to graph a scatter plot, I have the directions here in this little box. So if you press the stat button on your calculator, so your stat button, which is under delete next to the arrows, and then you're going to select the first option. Yeah.
Those are 10, 9, not 10, 11 points.
Oh, cool. That means I fixed it on yours. Okay. Okay. So you hit the stat button, and then under the first option should say edit, so you hit enter. And then you should see a bunch of lists. Say L1, L2, L3 on your screen. Does everybody have L1, L2, and L3?
No.
So you hit stat and then edit.
Edit. Yes.
Okay. Anybody else not see? If those lists ever disappear, you gotta let me know. So that's kind of what I'm saying here. If you ever have stuff like typed in from a previous problem in your list and you want to clear it, you just hit the up arrow. So like L1 is highlighted, and then you hit clear, enter. Do not hit delete, because that will delete the entire row, and your calculator won't know what to do when you tell it to do a scatter plot. So don't hit delete. You want to clear stuff, hit clear, enter. But if you do accidentally delete one of your lists, just let me know and I can bring it back. Okay. So once we have our list, you're going to type your x values into L1. So you should have your cursor kind of highlighting that first spot under L1. You're going to type in your x values. So you'll do 2, enter, 4, enter, 6, enter, and so on with all of our x values. Then once you have your x values typed in, you're going to hit the right arrow to go over to L2. Then you're going to type in all the y values. Make sure you do them in the same order that you did your x's, because they have to pair up so that they're the points. So we'll type in all our y values. Then when you get to the bottom of your list, make sure that you have the same number of data values in each list, that you didn't skip anything. Okay, then you're going to hit the graph button. If nothing's showing up on your screen, that's okay. Just hit the zoom button, which is in the middle of the top row of buttons. And you can try option 6, Z standard, or zoom stat. If you scroll all the way down to number 9, that's zoom stat. So hit zoom and then number 9. And then it should bring it so you can see your points. All right, so that's a way you can use your calculator to graph your scatter plot if you don't want to do it by hand, but sometimes you will have to do it by hand, so make sure you're good with both. And now, Quinn, now down here in this box, we're going to use our calculator to determine our linear regression line and the correlation coefficient, so we can see how strong or weak our relation is. But if we look at our scatter plot here, and you had to guess what type of relation this is, what would you guess?
Relation -1.
Yeah, why positive 1 and not negative 1?
Because it's a positive one.
Yeah, because it's increasing. So we are increasing, so we're going to have a positive. And are these points pretty close to a line? Yes, this would be a positive, a strong linear relation. So we can guess that r is going to approximately be close to 1, maybe like 0.9-ish. Okay, well, let's see for sure. Our calculator will tell us. So if you weren't doing your scatter plot, you would still have to enter in your x values into L1 and your y values into L2. So you would still have to do this step 2 in order to get your linear regression line. You'd still have to do that. Then once you have your data values typed into your lists, you're going to hit the stat button again, which again is underneath delete. You're going to go over to the calc menu. And you're going to go down to option 4. It says lin reg ax plus b in parentheses. And hit enter. Some you have to enter a bunch of times, but just keep hitting enter until a bunch of stuff pops up. It should say ax plus b, a equals, b equals, r squared equals, and r equals. If you're not seeing that, let me know.
How do you see this?
Yep, I said keep hitting enter until all that stuff pops up. Okay, so your calculator should pop up all of this, so let's go ahead and write in these values. So you should have had an a value of about 1.03 for rounding. B is negative 0.46. R squared is like 0.93. And R is 0.97. Did we all get these numbers? Yeah.
Are you allowed to round these like you ready to go?
Yeah. Yeah, I didn't write out all.
I wrote out all.
No, at least 2 decimal places. Yeah. Okay, so from this now, we can get this A and the B value are telling us our slope and our y-intercept for our linear regression equation. So A, again, is the slope. And this means as x increases by 1, A, or your y values increase because it's a positive, by 1.03. So as x increases by 1, y increases by 1.03. So you're going to have to be able to explain slope like this. So in this case, our x and y were just generic x and y values. They didn't have any meaning to them. But if x and y were representing something like test scores or temperature or something like that, you would have just put that in place of the x and the y. So it's slope is for every 1 increase in x, y increases by whatever your slope is. Okay, then B is your y-intercept. This is your initial value when x is equal to 0, y is equal to that value, negative 0.46. The r squared value we're not really going to worry about, so we can just cross that out. We are only focused on r, which is the correlation coefficient. So since r is a positive number, that means our relation is positive. Positive number means positive relation. And close to 1 means that we have a strong relation. So we were right in our guess when we said that we would have a strong, positive, linear relation. Okay, so you will have to know how to do this stuff in your calculator for a test and or a quiz. So as you do your homework and as you practice, just make sure you are aware of that and try to remember what buttons you're pushing. Any questions? Okay. So just one more thing. When we have this equation, guys, when we have this linear regression equation with your A and your B, Quinn,
Yeah.
when we have this equation, we can use this now to make predictions with our data. So whenever a question is asking you to predict, you'll just be plugging numbers into this equation and solving for the other variables. We can use to make predictions. Oops. So if I said if x is equal to 4, make a prediction as to what y would be, all you would do is plug in 4 for x and then evaluate. So 1.03 times 4 minus 0.46. If I said if y is equal to 42, predict what x would equal to. You would plug in x for, or plug in 42 for Quinn. You would plug in 42 for y and then solve for x. So this equation is used to make predictions. Okay.
Okay, little bot.